Hello, this is Dr. D, and today we are going to talk about the cardiovascular system. So what is the cardiovascular system? It involves the heart and the blood vessels that allow the passage of blood to and from the heart. Now there are two types of circulation, and that is the systemic circulation and the pulmonary circulation. So systemic circulation, it will carry oxygen and nutrients to all the body cells and removal of waste and carbon dioxide. Pulmonary circulation eliminates carbon dioxide and intakes oxygen from the lungs. So what about the coverings of the heart? Now there are two coverings. The pericardium covering, which is the covering of the heart, is the fibrous pericardium and the serous pericardium. The fibrous is the dense connective tissue which allows anchoring and protection. Serous pericardium, you should have come across this in 201, chapter 1. Please review your notes. It's the parietal pericardium and visceral pericardium. All right. Now here, if you look at the layers of the heart wall, there are three layers. Outer layer, epicardium, which is nothing but the visceral pericardium. The middle thick layer, which forms the bulk of the heart wall, is the myocardium, and the thin inner lining called the endocardium, which is made up of single layer of squamous cells, and it continues with the blood vessels. All right, now look at the heart chambers. There are two heart chambers on top and two below. So if I were to draw this, I see that there are two chambers, and this upper chamber is called what? It's called the atrium. And the lower chamber is called the ventricle. So there are two atriums and two ventricles. This one will be called the right atrium. And this one will be called what? This will be called the right ventricle. I'm going to write RV. What is this going to be called? This is going to be called the left atrium, and this the left ventricle. All right. So here, this is what's called a box drawing. I love this drawing. It helps me study this, and I studied it long back. It's very simple. Anybody can draw it. All right, let's look at the inside of the heart. So if you look at the inside of the heart, so let's go back to our box drawing. So what was this? We said this is the right atrium, right? So here is the pen is going to write when it wants to write. Right atrium, and this, what did we say? Right ventricle, right? Left atrium, and what did I say? Left ventricle, right? Now here you can draw another box, and I'm going to write lungs. And here I'm going to draw another body, which I'm going to write body. Okay, so from the body, deoxygenated blood is going to go into the right atrium. Okay. And this blood vessel is called what? Vena cava. So deoxygenated blood is going from the body into the right atrium. From the right atrium, the blood goes down into the right ventricle. From the right ventricle, another blood vessel goes from here, and this is called the pulmonary artery. And in the lungs, what happens? You exchange gases. So you give off carbon dioxide, take in oxygen, right? So another blood vessel will now take this and dump it right here. And what is this? This is the pulmonary vein. I'm just going to write in brief, okay? Because my pen is not working. From the left atrium, blood flows down into the left ventricle. And from the left ventricle, now again blood, which is oxygenated rich blood, is going to go into the body. And this blood vessel is going to be called what? Aorta. This is a very simple drawing. I'm going to repeat this, okay? From the body, carbon dioxide rich blood, deoxygenated blood, is going to go up the vena cava into the right atrium. From the right atrium, it flows down into the what? Right ventricle. From the right ventricle, it goes through this blood vessel, which is called the pulmonary artery, into the lungs. What happens in the lungs? Give off carbon dioxide, take in oxygen. So the blood leaving the lungs is rich in oxygen, called oxygenated blood, via what? Pulmonary vein. Pulmonary vein will dump it into the top chamber. What's the top chamber? It is the left atrium. From the left atrium, blood goes down into the left ventricle and out through the big vessel called the aorta into the body back. Very simple box drawing. I highly recommend that you study this before you start looking at this complicated structure. Now, what did we say? That there are two chambers on top. Yes, this is the right atrium, and I'm going to write it here, and this is the right ventricle. This is the left atrium and left ventricle. Yes. Now here is a valve, and because it has three flaps, it's called the tricuspid valve. All right. So you can see here's the tricuspid valve. Here there's a valve because the blood is going to go down. Okay. So as the blood goes down, here there are two valves. This is two flaps, and because of the two flaps, it is called bicuspid. All right. So here it should be the bicuspid. Now another name for it is mitral valve. So tricuspid, bicuspid. There are three flap-like structures. So tricuspid, bicuspid. Now from the right ventricle, what did I say? Blood goes out, right? So when it goes out, here there are two, these are half moon shaped structures, flaps, valves. And this valve is called the semi-lunar valve. Why? Because they look like the moon. Okay, so this will be semi-lunar valve. Now, same thing, what did I say? From the left ventricle, aorta goes out, right? And aorta, same thing. Guarding the entrance of the aorta from the left what? Ventricle into the aorta, there are two half moon shaped valves. I'm drawing it very poorly. I'm going to draw it here so you can see. Like this. And these valves are called semi-lunar valves. So again, this is also called semi-lunar valve. And this is also called semi-lunar valve. Semi-lunar will prevent backflow of blood from where? Right ventricle to the pulmonary what? Artery. Semi-lunar valve also will, another semi-lunar valve will also prevent the flow of blood from the left ventricle into aorta. Two different valves have the same name, semi-lunar valve. Now your book says this is called pulmonary valve and this is called aortal valve, aortic valve. Both are correct. But, we were taught semi-lunar, so that's why I'm telling you semi-lunar. If you want to, you insist on calling it pulmonary valve and aortic valve, both are correct. Please learn these simple drawings before you jump in and learn complicated structures. All right. Now here, what you notice is, in addition, when you are noticing this tricuspid and bicuspid valve, so which are three flap-like, right? Like this, right? Here. They are going to be held down by thread-like structures. Why? Because when the ventricles will contract, it's not a bone, it's a thin, fleshy piece, flexible piece, and when they close, then what happens? Prolapse can take place. These valves can go into the aorta right here. So they are guarding the entrance from the aorta into the ventricle. You understand this? So these thin-like, thread-like structures holding them, these are called the chorda tendinae. Here's the spelling. And chorda tendinae is anchored into these, okay, finger-like projections. And these finger-like projections on the walls are called the papillary muscle. Got to know this. Do you understand? So here's the tricuspid, here's the bicuspid. Same thing. You'll have chorda tendinae and papillary muscles. All right. So now let's see if I'm missing something. Okay, let's go on to the next slide. the valves. So we talked about what? We talked about the tricuspid, the bicuspid valve. We talked about the aortic valve and the pulmonary valve. What did I say? Pulmonary valve and aortic valve can both be called, what did I say? Semi-lunar valve. What is lunar? Should remind you of what? Moon, right? So half crescent. And then there is the tricuspid, and then there's the bicuspid. Another name for bicuspid is mitral valve. Valve malfunction, leaky valves. This is, it has to be fixed. Mitral valve prolapse, when what happens is that these don't close properly. And then there's the valvular stenosis, where the stiffness of the valves with age. This is because of the scar tissues, which constricts opening, very, very common with people with cholesterol deposit. So here, this will lead to heart not functioning to its full extent. And therefore, a surgical replacement is necessary, which can be from the pig or cadaver or mechanical. So you have heard of stent being placed. Well, that's what it is. All right. Blood supply. So I'm going to jump on to this because it explains it very well. So here from the aorta. Now, one second. What I said was that this is a coronary circulation. So along with the pulmonary, along with systemic, there's something of coronary circulation. So heart is a muscle, and for a muscle to contract, you have to have what? You have to have ATP. Now, to have ATP, you have to have oxygen. Again, for this, you'll have to look at aerobic respiration, all right, cellular respiration, and go back to 201 for that, all right. So obviously, you have to have a very good blood supply to bring oxygen to the heart muscles. Otherwise, the heart muscles will not have ATP and therefore not contract. So from the aorta, you notice that there's right coronary artery, left coronary artery. The right coronary artery goes into the interventricular artery, the posterior one, and the marginal artery. The left coronary artery goes into the circumflex artery and the anterior interventricular artery. The posterior interventricular artery provides the ventricular walls. Anterior interventricular artery provides the ventricular walls. Marginal and circumflex artery will provide blood to the atrium and the ventricles. Notice the ventricles are repeated twice. Why? What is the reason? Why there's so much of circulation of blood to the ventricles? Notice, which ones are the muscles that are the most, right? The thickest muscles you are finding in the ventricles. Thinner muscle wall is there in the atrium. Atrium is small, muscle wall is thin. Ventricles are large, muscle wall is thick. Therefore, we'll need what? More oxygen and ATP, right? So here, obviously, you will have a double circulation for the ventricles. Blood is collected back by the cardiac veins into the coronary sinus, important, and which flows into the right atrium. We are back. All right. So here, I will stop here and continue in my next slide. So I thank you for listening to me. If there are questions or concerns, please contact me. Thank you. Have a good day.